Hey guys, welcome back to the channel. I'm Satyam Dhaman. I'm the student of BTech Computer Science. So today I'm here with you all, the all new video on the trees. So let's discuss that. What are trees? So basically, tree is a data structure. It is a non-linear data structure in which a collection of element is known as nodes and are connected to each other via edges such that there exists exactly one path between any two nodes. So you all must be thinking that a Y tree is considered as a non-linear data structure. The data in a tree are not stored in a sequential manner. That is, they are not stored linearly. Instead, they are arranged on multiple levels, or we can say it is a hierarchical structure for this reason. The tree is considered to be a non-linear data structure. So here are some basic terminologies in the data structure. So let's just discuss one by one. Basic terminologies and tree data structure. So first we are going to discuss about the parent node. So basically the parent node is a node in which a predecessor of a node is called the parent of that node, and it is connected to the another node. So next we are just going to discuss about the child node. So basically, first let me just write the names of these basic terminologies, then I will explain it with the help of the example. So first terminology here was a parent node, second was a child node, third one is the third one is the uh, third one is the root node, fourth one is the leaf node or the external node or external node. Fifth one is ancestor of a node, sister. And then is there the descendant after descendant there is level of a node, and the last one is, wait, there are one more, internal node. Then siblings, and the last one is subtree. So these were the basic terminologies in a tree in a data structure. First was the parent node, then second is child node, third is a root node, fourth is leaf node or external node, fifth is an ancestor of a node, sixth is descendant, seven is level of a node, eighth internal node, ninth is sibling, and the last one is subtree. So let me just make a diagram, then it will be more clear to you. So this is the diagram. Now let me just link it with this. Here you can also in this diagram, just wait a minute. So in this diagram, here you can see that this is the parent node, this is the child node here, and this the Dij. It is completely making the subtree, and here the K and F. They are the leaf nodes, and F, G, and H. These are the siblings, and these are the edges. The connecting these lines. These are the edges, and it is the root from where these all are connected. So now let's discuss one by one that what are the basic terminologies here in this diagram. So first of all, we come to the parent node. So the node which is a predecessor of a node is called the parent node of that node. Here the B is a parent node of the D and E. Next we come to the child node. The node in which immediate successor of a node is called the child of that node. Here the examples are D and E are the child nodes of the B. And after that we comes to the root node. So the topmost node of the tree, or the node which does not have any parent node, is called the root node. Here is the root node of the tree. A non-empty tree must contain exactly one root node and exactly one path from the root to all other nodes of the tree. Next we come to the leaf node or the external node. So the nodes which do not have any child nodes are called the leaf nodes. Here, here the leaf nodes are K. Here the leaf nodes are the K, means it is not having any child node, means it is not having particular part here. So next we come to the ancestor of a node. Any predecessor node on the path of the root to that node are called the ancestors of that node. A and B are the ancestors of the node of E. Means ancestors are means something like Purvaj means the grandfather or grand grandfather, something. You can just relate it with that. So here the AB are the ancestors of the E. Next we come to a descendant. Suppose a node X is a descendant of another node Y. F and only if Y is an ancestor of X. Okay. So next we come over to the siblings. So sibling children of the same parent node are called the siblings. That is here you can see that D and E are the siblings are the siblings, and they are of the same parent. That is the B. Okay. And next we come to the level of a node. The count of edges on the path from the root node to that node. The root node has level 0. Okay. So next we come over to the internal node. A node with at least one child is called the internal node. A neighbor of a node, neighbor of the node. A neighbor of the node, parent or child nodes of that node are called the neighbors of that node. Uh, and last we come over to subtree. Any node of the tree along with its descendant is known as the subtree. Here you can see that this particular forms the subtree. Okay, and these are the leaf nodes F and K, and this is the parent node. D is the parent node. I is the child node. And this one is the edge, and A is the root node. And these are the siblings. These F, G, and H. Because it has the same parent. So now moving next, that what is the importance of tree data structure? So one reason to use trees might be because you want to store information that naturally forms a hierarchy. For example, the storing a file a system on a computer. And the trees with some ordering, example BST, providing moderate access search, quicker than linked list, and slower than arrays. Third, trees provide moderate insertion and deletion than arrays and slower than unordered linked list. And fourth, like linked list and unlike arrays, trees do not have an upper limit on the number of nodes, as nodes are linked using pointers. So tree data structure can be classified into three types based upon the number of children each node of the tree can have. So these types are the binary node tree. So these types are the binary tree, then a ternary tree, then an array of a tree or the generic tree. So today we will just discuss more especially about the binary tree. So let's discuss that what are these three types of trees. So first is the binary tree. In a binary tree, each node can have a maximum of only two children linked to it. Some common types of binary trees include full binary trees, complete binary trees, balanced binary trees, and degenerate or pathological binary trees. Ternary tree. A ternary tree is a tree data structure in which each node has at the most three child nodes, usually distinguished as left, mid, and right. An array tree or generic tree. Generic tree are a collection of nodes where each node is a data structure that consists of records and a list of references to its children. That is, duplicate references are not allowed. So unlike the linked list, each node stores the address of the multiple nodes. So now let's just discuss about the binary tree. And we will so in a binary tree, each node can have a maximum of two children linked to it. Some common types of binary trees include full binary trees, complete binary trees, balanced binary trees, and degenerate or pathological binary trees. So there are some basic operations that we can perform using the binary trees. So those are the first one is the insert. So the insert operation involves adding a new node to the tree while maintaining the binary search tree properly. This search this property states that for any node in the tree, all nodes in its left subtree have values less than the node's value, and all node in its right subtree have values greater than the node's value. To insert a new node, you can start at the root. To insert a new node, you can just start at the root and recursively traverse the tree. Comparing the value of the new node with the current node, if the new node's value is less than the current node value, if it is you move its left child. If it's greater, you move it towards the right child. This continues until you find an empty spot where the new node can be inserted. The second operation is performed the deletion operation. So the delete operation, on the other hand, involves removing a node from the tree while maintaining the binary search tree properly. There are different cases to consider when deleting a node. If the node to be deleted has no children, simply remove it from there. Now for example, if the G, we just move it further, if it is not having any children, then we can just delete it. So if the node to be selected has two children, find the node with the next larger value in the right subtree or the next smaller tree, and then replace the node to be deleted with the successor. And if the node to be deleted has only one child, replace the node with its child. Okay. So now let's talking about the traversal techniques. So the tree traversal includes the various ways to visit all the nodes of the tree. So traversal refers to the process of visiting and assessing each node of the tree exactly once in a certain order. Tree traversal algorithms help us to visit and process all the nodes of the tree. Since tree is not a linear data structure, there are multiple nodes uh, which can visit after visiting a certain node. So a tree data structure can be traversed in following ways. Uh, that is in the depth first search or DFS. So this includes the of three types. So those are those three types are the in order, pre-order, and the post-order traversals. So it helps us to just assess each node in a tree. So first, let's just discuss about the in order traversal. So let me just explain it with you with the help of the example. So suppose here we made a binary tree. So in this, the algorithm for the in-order traversal is uh, when it will just move from the root, traverse the left subtree that is called the in-order, and then visit the root, then traverse the subtree that is called the in-order. That is right of the subtree. It means just wait, the in-order traversal here is. So in this, the in-order traversal is the 4, 2, 5, 1, 3, 6. Means like we said that it will just move from the left of the wait a minute. So like we have said that first just traverse from the left subtree. So this is particular subtree. So first it just went from the left subtree, that is from the fourth to 2. Then it just went from 2 to 5, and after that it just went to its the root, and then it went to the rest of the traversals, then to 3, then to 6. Means its basic motive is just to reach the each node. So now let's move on to the pre-order traversal. So as moving on towards the pre-order traversal, first let's just discuss the uses of in-order traversal. In the case of binary search trees, in-order traversal gives nodes in non-decreasing order. To get nodes of binary search trees in non-increasing order, a variation of in-order traversal where in-order traversal is reversed can be used. In-order traversal can be used to evaluate arithmetic expressions stored in expression trees. So, as now coming towards a pre-order traversal. So, in the pre-order traversal, first it moves towards the it's just start from the root from the left side, and then it just like just wait a minute. So this is a particular route when it just moved from the here. Then we went to a second, and after a second it again moved to the left. Then when it just reached to it and then it just moved to the right of that part, and then it just moved towards the right of the subtree, and then it just covered all the subtrees. So let me now just write the order of this. So first, it from its roots it just went to the left side, that is on the 2, and then it towards the right side. After that, it just shifted on towards the right side again, that is the 5th, and then it just went to the uh, second node, that is the 3rd, and then to last one is 6. So basically, in a pre-order traversal, it is used to create the copy of the tree. That is, pre-order traversal is also used to get a prefix expression on an expression tree. So moving on towards the next tree, that is the post-order traversal. Post-order traversal visits the a node in the order left to right, like the this is the end of the node, and it will move towards the left to right and to the root point, and then it will just cover all the points. Uh, so now let's just write the order of this. Post-order traversal. So as I said that it will just move towards the left to the right and then to root point. So we will start here from the 4, 5, 2, then 6, then 3, then 1. So basically, post-order traversal is used to delete the tree. Uh, so uh, post-order traversal can help in garbage collection algorithms, particularly in systems where manual memory management is used. So I hope that you just got a little bit idea of the post-order, pre-order, and the in-order traversals. So now I will just do a code, and then it will be just more clear to you. Let's move towards the coding part. So first we will just create a class here. Class tree node, then define class tree node, then define init self of data, then self dot data equals to data, self dot left equals to null, self dot right equals to none. So this part defines a class named the tree node, representing a node in the binary tree. The init method initializes here a node with the given data. In this, so each node has a three attributes, that is data left, data and data right. The here self dot data stores the data value of the node. Self dot left and self dot right are pointers to left and the right child nodes respectively. So as moving forward, again we will create a class here that is a binary tree. Then we will define a function in it of self. Then self dot root equals to none. And define insert self of data. If not self dot root, then self dot root equals to tree node of data. Else self of insert recursive x to self dot root data. And again define a function insert a recursive of node of the data. So basically, this part defines a class named the binary tree, representing the binary tree itself. The init method initializes an empty binary tree with the self dot root set to none. So we now created here a new class, a new definition that insert of recursive. If data is less than node of data, if node dot left insert dot insert recursive node dot left, else node dot right equals to self of insert recursive node dot right of data, else node dot right equals to tree node of data. Then again define a function delete self of data, then self dot root equals to self of delete recursive self dot root of data. Then define delete recursive self node of data. If not node, then return none. Node dot left equals to delete of recursive node of left of data. And then left data is greater than node dot data, then node dot right equals to self dot delete recursive, else if node dot left and node dot right, then return none. Elif not node dot left, then return node of right. Elif node dot right, then return nodes. Minimum of node equals to self of find minimum node dot right. Then node dot data equals to minimum node of data. Then node dot write equals to self dot delete recursive node. Then again define a function find of minimum self of node while node dot left node equals to node dot left return mode return node. Then again define a function that is of the in-order traversal. Then self dot in-order recursive self dot root, right? Then define in-order recursive self of node. Then self dot in-order recursive node dot left. And print node dot data end equals to empty. Then self dot in-order recursive node dot right. Then define the pre-order traversal self dot pre-order. Then print define pre-order recursive. Yeah. And then print node of data. Then define a function post order traversal self dot post order recursive self dot root. Then print. Then define post order recursive self dot self comma node f node. And then self dot post order recursive node dot left. Then print node of data and equals to empty. So this was the particular code for the basic operations while inserting, deleting, and for the in-order traversal, for the in-order recursive, pre-order traversal, and pre-order recursive, then post-order traversal and post-order recursive. Now let's do example, then it will move clear to you. So before as just moving on to the example, I would just like to introduce that the insert method here. Yeah. So the insert method inserts a new node with the given data into the binary tree. And if the tree is empty, no root node, then it creates a new root node with the given data. Otherwise, it calls the insert recursive method to insert the data recursively starting from the root node. So then the insert recursive method is a helper method to insert data recursively. If the given data is less than the data of the current node, then the node.data it recursively inserts the data into the left subtree. If the given data is greater than or equal to the data of the current node, it recursively inserts the data into the right subtree. So now let's do an example here. If underscore name equals to main, then tree equals to binary tree dot insert of 30 70 20 40 60. Then print in-order traversal. Print pre-order traversal. Then print post-order traversal. Print deleting node 30. And tree dot delete 30 is equals to print of in-order traversal after deletion. Then tree of in-order traversal. So this is a particular example. So now let's check that if the code is working or not. So as you saw that how the particular code works. So basically in the in-order traversal of binary tree, you visit the left subtree, then the root node, and finally the right subtree recursively. So this traversal is called the in-order because you are visiting nodes in increasing order when the tree represents the value. So now as coming over to the pre-order traversal, in a pre-order traversal of binary tree, you visit the root node first, then recursively traverse the left subtree, and finally the right subtree. This traversal is called the pre-order traversal because you are visiting the root before its children. And last but not the least, the post or traversal of binary tree. In this, you recursively traverse the left subtree, then the right subtree, and finally visit the root node. So this traversal is called the post order because you are visiting the root after its children. So thank you guys. This was all about the video.